This is the second lesson in Unit 1 for 8th grade Accelerated Math. And in today's lesson, we're going to be talking about inequalities, but also some new notation that is not familiar to you. So you'll be learning some new notation as well as reviewing what you've already learned about inequalities. So let's get started. The first thing, we're going to talk about something called set notation and interval notation. And these are just ways of writing answers. So previously to this, what you've done is when you've solved an equation like x plus 2 equals 5, and you subtract 2 from both sides, you just write your answer as x equals 3. And when you solve an inequality, like x plus 2 is greater than 10, and you subtract 2, and you get x is greater than 8, and you just write that inequality. Okay, so that's what you've written so far. So what we're going to do is we're going to write it in a different, more mathematical way, and there's some different ways to write these different answers, and they're called set notation and interval notation. And so as we learn this year, you will start writing your answers in these notations, and it will become a lot easier than it seems today. If your solution is x equals 4, then set notation would be written in this format. And so what this is, these are braces, and you're going to write x, and then this vertical line means such that. So x such that x equals 4, and then you close your braces, and that's set notation. Now, I will agree that right now you're looking at that thinking, why do we have to write it like that? That's just a lot more work. Okay, first of all, let's be honest. It's not any more work. It's just more writing, okay? But sometimes in math, like that's how we notate things, and that's when you get higher and higher in math, you learn that. And so we're learning to do that now with really simple answers so that when we have more difficult things that we're writing in set notation, it will be easier. And so we're going to start learning that now. So yes, I agree that it's kind of a pain for simple answers like that, but we're going to start learning to do that when the answers are small so that when they're big, it's not that big of a deal. Okay, if you have an answer like x is less than negative 2, so that's an inequality, then set notation is going to look very much the same. It's going to be the braces x such that x is less than negative 2. So really, you're just writing just a couple of extra marks. Okay, so remember, it's not extra work, it's just extra effort. Okay, now the next thing, this is set notation right here. That's set notation. And so the next one, it says if your solution is x is less than negative 2, then our solutions go from negative 2 at the higher end, the larger end, down to negative infinity at the smaller end. I'm not sure why I have parentheses there. Okay, so let's look at this on a graph. So if I have an inequality and I've got x is less than negative 2, I have negative 2 right here, negative 1, negative 3. I have an open dot right there, and it's going to be all of those. That means that all of these numbers are part of my solutions, and they go on forever and ever, all the way to negative 1,000 and negative 1,000,000, negative infinity. And so if I'm writing this as an interval, which is what we're going to talk about here, an interval is like from here to here. That's an interval. So if I write interval notation, the way I'm going to write that is I'm going to say x, let me write it bigger, x, and then you have this funny looking e. It's like a C with a line through it like that, and that means is an element of. X is an element of the interval. You always must start your interval with the smallest number. So in this case, I've got negative infinity and I've got negative 2. The smaller number is negative infinity. And so if you're looking at it on a number line, you're going to always start at the left and go to the right, and then we're going to go to negative 2. So if you were just looking at this part, it looks almost like an ordered pair, but it's not because of the notation that's involved. And you are going to use parentheses when you're not including the number. So notice how we had an open dot right there? That means that negative 2 is not a solution. So I'm not including negative 2. That's why I'm going to use a parenthesis, and we'll talk about what to do if there's a colored in dot. Let me talk about infinity for a second. Infinity, or negative infinity, is represented by that symbol. It's kind of like an 8 on its side. And it's a concept. It's not actually a number. If it was actually a number, you could add 1 to it and have now infinity plus 1. So infinity is a concept of the greatest thing ever, or the smallest thing ever for negative infinity. So it's a concept, not a number. Okay, so when we write it in interval notation, so if I write x as an element of negative infinity to negative 2, I could include -2 if the graph dictated that, but I can never include infinity. So I'm always going to have parentheses around my infinity side of that. So as we do more examples, actually I'm not going to erase that. As we do more examples, that will make more sense to you, but I'm going to leave that part right there. Now the next thing, it says if your solution is x is greater than or equal to 5. Okay, that's different. So let's think about a graph for that. So greater than or equal to 5. I'm going to have a filled in dot, and greater than is going to go that direction. And so I am including 5. And so everything from 5 all the way to where? Where does it end? It ends at infinity. And so if I go to write my interval, I'm going to say x is an element of, I'm going to start at the smaller end, which is on the left of my graph. So I'm going to start at 5, and I'm going to go to infinity. I can never include infinity, so I'm always going to have a parenthesis there. But because of my filled in dot right there, I'm going to have a bracket on the 5 side of that because I'm including 5. So this is the way you would write your interval for that inequality. So we're going to practice writing interval notation and set notation for these things. Now interval notation, let me just write this. We're only going to use that for inequalities. It doesn't really make a lot of sense to use it if x is equal to 5. There's no interval. It's not from here to here. So an interval is just when you have a set of numbers that are between some points. Okay, so it says right here, infinity is not actually a number, so it's never included. Always put parentheses and use brackets for inclusive. So we use the words inclusive and exclusive a lot. So exclusive, you're going to use parentheses, and inclusive, you're going to use brackets. Okay, so we're going to solve some problems here, and we're going to write it in set and in interval notation. So number 1, we're going to solve by first combining our like terms. So 15 is less than or equal to -3b plus 5b, like that. And then how do you solve that? We're going to add 1. So I'm going to have 16 is less than or equal to 2b, and then I divide by 2. And I'm sorry I can't zoom this in better, but I'm going to have this number, 8 is less than or equal to b. Now you don't have to, but I'm going to recommend that where you're starting, you should graph it just so you have an idea of what that looks like. So I'm going to have 8, and it says 8 is smaller than all the answers. B is greater than or equal to 8. So I'm going to have this graph like that, and that helps me to see what's going on. And so I apologize for the small space. I can't zoom it in, but I'll do something different on the next problem. So I need to write it in set notation and interval notation. So first off, let me erase. Now you should show your work here. So if this was on a piece of paper and I could write smaller, I would not erase this, but I'm going to erase it so we have some space. And I'm going to write a couple of things. Okay, first off, we need to be clear that if it says 8 is less than or equal to b, it would help me a lot if I could write it like this. So notice that the arrow is pointing to the 8, the arrow is still pointing to the 8, so it's not saying anything different. You're just looking at this from a different perspective. It's like looking at your house from the front yard versus the backyard. The house is the same. Your perspective is different. Okay, so this helps because when I graph that, I'm going to graph that correctly. A lot of people, when they graph it incorrectly because they think the arrow just goes whichever way the arrow is going. So b is greater than 8. So for my set notation, I'm going to write b such that b is greater than or equal to 8. And that's my set notation. Now for the interval notation, that's why I thought it would be helpful if you draw this. So you can choose not to, but then you're very likely going to get this wrong, especially here at the beginning. So you're going to write b is an element of, and then my interval starts at 8, and it goes to infinity, and it never includes infinity. Is it including the 8? And the answer is yes. So these are my two answers for this problem. Okay, for number 2, I'm going to write this separately so I have a little bit more space. So on number 2, to solve this one, again, you start with what can I do to simplify it. So I look at this, inside my parentheses, 2b minus 2, I can't do anything with that. but I can distribute. So I'm going to distribute. So negative 10b plus 10. Watch your signs. And then I'm not going to do anything else. I'm just going to write down the rest of this. And then I look for like terms. I've got like terms right there. So negative 10b plus 7b. And then I'm going to get the v by itself. So I'm going to subtract 10. And negative 2, don't forget that negative, and negative 10 is negative 12. And then I'm going to divide by negative 3. Now there's something that you should have learned with inequalities. What happens when you divide by a negative? Do you remember? Okay, side note. Let's try a couple of problems here. I'm going to write some things down and you think about this. If I have 2 is less than 4, we'll all agree that that's a true statement. What if I add 2 to both sides? Then I have 4 is less than 6. Is that true? Yep, still true. Okay, what if I subtract 2 from both sides? Is it still true? Yep, still true. What if I multiply 2 on both sides? Still true? Yep, still true. What if I divide both sides by 2? Still true. What if I multiply both sides by negative 2? Is that still true? Would you rather lose $4 or lose $8? In order to keep that to be a true statement, you have to flip your sign. Okay, what if I did a similar thing, but what if I divided both sides by negative 2? Then that's going to be negative 1 and negative 2. Again, which one's bigger? It's going to go like that. So when you multiply, and you might want to write this down, especially if you don't remember this, but multiply or divide both sides by a negative, you flip your sign. And the reason why we do that is to maintain the truth of it. And so when you are working with inequalities, if you multiply or divide both sides by a negative, you flip the sign. Okay, so let's come back over here. I am dividing both sides by negative 3, so I need to flip my sign. So negative 3 divided by negative 3 is 1, and negative 12 divided by negative 3 is 4. So that's my answer. Now to write that in set notation, really all I have to do is just throw on a v such that, and write it like that. And then to do an interval, my suggestion is put it on a graph first, because that's really, really helpful, especially where this is unfamiliar territory to you. And graph it, and then to write your interval, you're going to say v is an element of, start at the left of your graph, negative infinity, and we're going to end at 4. It's going to include 4, not in negative infinity. Number 3, negative 1/3 b plus 2 is greater than 6. So when you're solving, remember you're going to save your variable for the end, and we're going to get rid of the constant. We're going to move everything to the other side. So I'm going to have negative 1/3 b is greater than 6 minus 2 is 4. Now please remember, you're subtracting, you're not multiplying, so we're not going to flip any signs. Don't start flipping signs when you're not supposed to. So when you subtract, you do not flip any signs. Now, in order to get b by itself, what do you need to do? We need to get rid of the negative 1/3. So what people like to say is they say, oh, we're going to divide by negative 1/3. And that's true. Do you really want to do 4 divided by negative 1/3? That's a pain. Nobody likes to divide fractions. And so another option that we have, and you can multiply this by the reciprocal. Because when you do that, you're going to have the 3's cancel, the 1's cancel, this is going to cancel, and you're just left with b. And it's a lot easier to multiply by negative 3 or negative 3 over 1 than to divide by negative 1/3. And so I like to always say I'm multiplying by the reciprocal. Now notice that I multiplied both sides by negative 3, so I'm going to flip my sign. And so when I write it as set notation, I'm write b such that, and then do that. And then for my interval, if you want to try it without the number line, that's fine. And I'm really experienced with this, like I've done it a long time, so I can But you're going to start with b as an element of, and then you need to think about, well, where's the negative 12 going to go? Is it infinity? Where is it? So it's really helpful to just kind of sketch this out. And we're going to have an open dot, so it's non-inclusive, and we're going to go that way. Okay, so we're going to start at negative infinity, never a bracket on that, to negative 12, and we're not going to have a bracket on that either because the open dot, there's no equal sign. Now I'm not going to do number 4, but you can look on the notes and you can see that one. Number 5 and 6, I just have a number line for you, and I want you to write what it says. So I'll just do one of those with you. So number 5, it's got negative 8, and it's got a filled in circle going that way. So I'm going to write x such that x is greater than or equal to negative 8. That's my set notation. And x is an element of, it's going to start at negative 8 inclusive, and it's going to go to infinity like that. So that's what I want you to do for 5 and 6. For number 7 and 8, I'm giving you an interval, and I want you to write the inequality and then graph it on a number line. It doesn't say you have to write it in set notation. What I would do is I would graph it on the number line first. So negative infinity to 7, so I know I need to have 7. I need to have something else around it. You see the square bracket? It's going to be a closed-in circle, and I'm going to go to negative infinity that way. So that means that x is less than or equal to 7, and that's my inequality. So you go ahead and do that for number 8 as well. Okay, numbers 9 and 10 is just translating in from an English sentence into a math sentence. And so this is just using vocabulary. So we say half the sum of x and y. So the sum of x and y, that's what I'm adding together. And I'm going to take half of that sum. And I'm going to use parentheses, because if I don't use parentheses, then I'm just taking half of x and adding it to y. And then it's decreased by 1/3 y is at least. All right, what does at least mean? If I say I want at least 3 pencils, can you bring me 3? Can you bring me 4? Okay, so yeah, I can bring exactly 16 or more. And so that's all you need to do there. I'm not asking you to solve it. I just want you to write what it says. So I want you to pause the video and try number 10 and then come back and see if you did it right. Okay, number 10, it says negative 8 added to the quotient. Okay, quotient means divide. And if you're doing these videos or if you're doing your lesson and you don't remember what a word means, Google it. Okay, or look it up. But there's no reason why you have to go on not knowing what the word quotient means. The quotient, I'm going to divide, and so I'm going to do k squared and 4. Now in math, it is, a lot of people, they like write it like this. Don't write it like this. Divided by, or k squared, divided by, don't do that. That's not a good way to do it because we can't really do an operation with that. The division sign, it really is a fraction. It's numerator, denominator. That's what this is. And when you do math, it is better, and I want you to do your division like that. Okay? Is no more than. So if I say you can have no more than 3 tardies, can you have 3? Or can you only have less than 3? No more than means I can have that many or less. So that's what that inequality is. Again, I'm not asking you to solve it. I just want you to write it. Okay, I'm going to go ahead and finish this on the second part of the video. And so we'll continue on that next one.